Hi, welcome back. Hononegah, Algebra 1. This is going to be the Chapter 6 review. So it does include 6.1 that we had a test on, and then it will include then 6.2 through 6.6. So preparing ourselves for the Chapter 6 test. So let's start with our exponent rules. So if I have a parenthesis raised to an exponent, everything in the parenthesis needs to be raised to that exponent. So 2 to the third, a to the ninth, b to the 12th. So that is taking everything in that parenthesis raised to the third power. And then -4 to the second. So notice that because it's a negative, you should always put it in parentheses anytime you're raising it to a power. So a to the 8th, b to the 10th. Now, multiplying. I need to evaluate all numbers. So on my calculator right now, I'm going to figure out what 2 to the third is times -4 to the second. So I'm multiplying these two together. And that is actually where most people have their problems, is on the numbers. So 2 to the third is 8. -4 to the second is 16. And so multiplying those two together, 8 times 16, you get 128. And that is the most missed part. The a, you add the exponent, and the b, you add the exponent. So again, a lot of the problems come on the number more so than the actual exponent. So the next one, 10 divided by -5. Again, you treat that like a fraction. 10 divided by -5 is -2. Now, exponents. We're going to subtract the exponent. So m to the second over m to the 10th. If I subtract, I get m to the 8th on the bottom. N to the 15th over n to the 8th, I get n to the 7th on top, and there is no other p. Last one on the page here, last one in this section. Everything in the parentheses raised to the exponent. So the -4 gets taken to the second, a to the 6th, b to the 12th, a to the -16, b to the 6th. Now, negative exponent means it needs to move. So I have -4 to the second, a to the 6th, b to the 12th, a to the 16th, over b to the 6th. So now it's a matter of just dealing with the number and dealing with the exponent. So -4 to the second power is +16. B to the 12th, b to the 6th makes b to the 6th on top. And a to the 6th and a to the 16th are both already on top. So I'm going to add the exponents. Next, also in section 6.1 deals with scientific notation. Scientific notation is dealing with powers of 10 or in decimal places. So anytime the number is bigger than 10, then we have to deal with positive powers of 10. So 5.4 and 1, 2, 3, 4, 5, 6, 7 decimal places. So again, you're counting the decimal places that you are actually making it go down. Next one, we have a small number. So we're talking about 1.234 times 10 to the -6 decimal places. So again, scientific notation is counting powers of 10. And if it's a larger number, it's positive powers of 10. And if it's a smaller number, it's negative powers of 10. Going backwards now, counting decimal places. So 1, 2, 3, 4, 5, 6, 7, 8 decimal places, going smaller, and then 9 decimal places going larger. So again, you're counting the number of decimal places that something is going up or that something is going down. Rewriting. We just took a quiz on this a little bit ago, but we're rewriting this in exponent form. Here's what I would tell all of you. Whatever is inside the radical, the exponent goes on top, the root goes on the bottom. So this is 20 to the 7/3. Now I do want to do a negative. Anytime you have a negative, make sure you put it in parentheses. So I'm adding that question here. Anytime you have a negative, make sure you put that in parentheses when writing it to an exponent. Evaluating. Now you're talking about using, rewrite it in radical form, sorry. So remember, the power goes on top and the root goes on the bottom. So this would be the fourth root of 18. And you can put 18 to the first if you want, but the root is on the bottom, the exponent is on top. So now, evaluate. Anytime they're using the word evaluate, now they're asking you basically to pull out a calculator and to actually figure it out. And you can do it in radical form on your calculator, or you can type it in exponent form. And I think exponent form a lot of times is easier to type in on a calculator, because now all I have to do is 512 raised to the 1/3 power. And so the answer to this question is 8. So when they're asking you to evaluate, they want to know what it actually is. So then 125. Now I'm going to show you how to do this if you weren't going to use a calculator, but I'm going to change the 125 and the 5 to the third, which cancels that out, and the answer to this one is 625. So next one, 78,125 raised to the 1/7 power, if you went ahead and put it in. 78,125 raised to the 1/7. Sorry, I typed it in wrong. 5 is the correct answer. And then the last one, negative 16,807 raised to the 2/5 power. And you get 49. So again, evaluate each of these. Basically, they're asking you to come use a calculator and to calculate what that value would actually be. Next section. Determine whether or not it's exponential or linear. I'm going to slow down here a little bit. If you want something to be linear, that means you have to add the same amount each time. Whatever that amount you're adding is your slope, and whatever the y-intercept is your b. So if you determine that it's linear, you have your slope and your y-intercept. If you determine it's exponential, now you're multiplying by a number each time. The a value is your y-intercept, and your b value is the number that you're multiplying by. So I'm looking at this, plus 2, plus 2, plus 2, plus 2, which, by the way, you're always looking at the y value when you determine that. So it's linear. So y equals 2x. And then I'm looking for the 0. I'm looking for the y-intercept. It's 2x plus 8. Next one. Again, decide if it's linear or exponential. This one times by 2. So that's exponential. Y equals. Again, we're looking for the y-intercept. 10 times 2 raised to the x. Evaluate. Again, anytime they're asking you to evaluate, they are asking you to put the number in and use a calculator to calculate. 2 to the 5th power is 32, and so 6 times 32 is 192. Next, XY chart. So now you're going to put numbers in for x. Now I see it's x plus 1, so I usually start with then -1. The value that makes it 0. If you just went from 2 to -2 every time, that's going to work for you. So now I plug those numbers in, and this is where I use the graphing calculator in my class. So I put y equals 3 parentheses 2 raised to the x plus 1 into the y equals function, and then use the graph function. But if I put 1 in, I get 12, 0 in, 6, -1 in, 3, and then 1.5 and 0.75. So I graph these. 6, just off there a little bit. -1, 3, -2, 1.5, and so on. So there is our exponential curve. Domain. The domain is always going to be all real numbers. It's all about the range. The y values are on the top side, so y is greater than 0. Determine whether the function represents growth or decay. Here's what you're looking at. The value that is being raised to the x power. Is that value above 1 or below 1? If it's above 1, you'd put growth. If it's below 1, you would put decay. So again, going through each one of these, the first one is below 1. Now, to find the rate, if it's below 1, I'm going to set that equal to 1 minus r. If it's above 1, I'm going to set it to 1, if it's above 1, I'm going to set it to 1 plus r. If it's below 1, I'm going to set it to 1 minus r. You're always going to subtract 1. And then write it as a percent. So you're going to subtract 1 and write it as a percent. You're going to subtract 1 and write it as a percent. So every single time, you're basically subtracting 1 and writing it as a percent. They're going to give you a formula. They want you to write a function. A is the initial amount, R is the rate. So you're starting with an annual salary of $38,000, and you have a rate of 4%. Now, that 4, written as a decimal, is 0.04. Use the function you wrote to find at 6 years. So now, calculator, 1 plus 0.04 raised to the 6. So I'm going to type that in my calculator, 38,000. Parentheses 1 plus 0.04 raised to the 6th power, I'm going to get $48,082.12 since we're dealing with money. Next one, we're dealing with people. 80,000 people. 1 minus 0.03. The reason it's minus is because it is decreasing, raised to the t. And now they want to know how many people. What would the population be after 6 years? So 80,000, 1 minus 0.03, and I'm going to raise that to the 6th power. And I can make the argument, since we're talking about people, that you could round this to the nearest person. Here's what I told my class. If the bases are the same, you can solve the exponents. So if the bases are the same, take the exponents and solve. So if I subtract x and I subtract 7, I'm just running out of space, I get x to be negative 10. I don't know if I can, nope, move it down just a little bit, but x is negative 10. Now, what happens if the bases are not the same? That is the key question now. Anytime the bases are not the same, you need to reduce it to make them the same. So 125 is the same as 5 to the 3rd. So I changed the 125 into 5 to the 3rd. Now, I have an exponent that is raised to another exponent. In chapter 6 or in section 6.1, I would multiply those two together. Now the bases are the same. So I'm going to set the exponents equal. I'm running out of space. I'm going to apologize right now. There's probably a glitch right now because I went ahead and switched this to try to give myself some more space. So I apologize for that. So I'm going to erase this part up here, and now we're going to go again. So I changed the 125 into 5 to the 3rd, and then I did power to a power. And then I already have, so now the bases are the same. Solve the exponents. And so I'm going to subtract 2x and subtract 6. And so the answer is negative 9. So again, I gave myself some more space, so I apologize if it is glitching a little bit. So the next one, 3 to the 2nd. I'm going to change the 9, breaking it down into something that's smaller. 3 to the 3rd. I'm going to break 27 down into something that's smaller. Power to a power, I multiply the 2 powers together. Once the bases are the same, solve the exponents. So I'm going to subtract 2x and divide by 2. X is equal to 4. Next one, now fractions. Anytime you have a fraction, it's going to just be a negative exponent. So 8 is 2 to the 3rd. So 1/8 is 2 to the negative 3rd. power to a power, I multiply the two powers together, so negative 3 times x, and subtract x. And solve. Next, arithmetic versus geometric. If it's arithmetic, you're adding or subtracting the same number every time. If it's geometric, you're multiplying by the same number every time. So in this first one, it's minus 3, minus 3, minus 3. So that is arithmetic. And all you have to give for a reason is the fact that you're subtracting 3 each time. Next one, multiplying by 3 each time. Again, the only reason you need to give is that it's multiplying by 3 each time. Next, write the next 3 terms. So now we're talking about find what's happening. So it's timesing by 5, and then write the next term and the next term after that. So multiply by 5, multiply by 5. This one, I wouldn't disagree if anybody said it's dividing by 2, but it's technically multiplying by a half. So multiply by a half, and then multiply by a half. So now, last thing. You are going to be given this formula. I need to know a sub 1 and r. So those are the 2 things I need to know. A sub 1 is the first term of the sequence. So a sub 1 is 0.6. R, what's happening each time? It's multiplying, and it's multiplying by negative 5 each time. So this is now calculator time. They want a sub 10. So I'm going to pull out a calculator, and I'm going to type in 0.6, negative 5, raised to the 10 minus 1. So this is what I am typing in right now to my calculator. And I get, and this is a big number, 1171875. So we're talking about negative 1,171,875. Next one is multiplying by a half again. So a sub 1 r raised to the n minus 1. So again, typing this into my calculator, 320, a half, raised to the 10 minus 1. 0.625. All right, so that is the end. If you have any questions, please make sure you talk to your teacher, and good luck.